welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. Students, as per my promise, I have completed my syllabus and now we are continuing with the IIT Foundations JEE level. In my last sessions, we have discussed about limit. Today we continue with this. You know students, this is very important chapter for JEE IIT level. In my last sessions we discussed about this. Today we continue with this. Now let us discuss what is limit. When you clear, it is an important chapter. When you clear about limit, then can you clear about derivatives. When you get profound knowledge about limit, then can you get knowledge from derivative. Then can you understand the derivatives. When we say that the limit exists, when LHL, left hand limit, is equal to the RHL, right hand limit, then can we say that the limit exists. Okay. Now let us discuss some questions. I have already told you students, only knowing theory is not sufficient. In my last sessions we have discussed about what is LHL, what is RHL. The LHL means the left hand limit, RHL means the right hand limit. When the LHL is equal to RHL, then can we say that limit exists. What do you mean by LHL? LHL means when the suppose limit x tends to 0 of fx, then LHL means limit x tends to 0 minus of fx, and RHL means, this is LHL, RHL means limit x tends to 0 plus for fx. This is RHL. When the LHL is equal to RHL, then can we say that the limit exists. Now let us discuss some examples to clear about this theory. Okay. Now let us discuss. Please students, you practice your exercises, your worksheets, and ask me your doubt. I am ever ready to clear your all doubts. Okay. Now let us discuss some examples. Please note down students the important points. Now let us discuss some examples. Example 1 says that, how can we find the LHL? Suppose here the question is given, evaluate the LHL and RHL of, here the fx is given. Here in this questions the fx is given x minus 4 upon x minus 4 when x is not equal to 4, and this is fx is equal to 0 when x is equal to 4. Then find the LHL and RHL when x equal to 4. Now let us find the LHL and RHL. You know what is LHL and what is RHL? I have already told you what is LHL, the left hand limit. When the LHL is equal to RHL, then can we say that the limit exists. Here LHL of fx is at x equal to 4. This means limit x tends to 4 minus LHL, 4 minus of fx, which is equal to limit h tends to 0 of 4 minus h. As this is LHL, the left hand limit, then we say that the x tends to 4 minus, means slightly, then this is 4 minus h. Then when we find out the LHL, let us keep it here and now discuss. Let us keep it here. Let us keep it here. Now let us discuss. The find out the LHL. Then the limit x tends to 4 minus, means the limit h tends to 0 of 4 minus h is equal to limit, you know that what is fx? Fx is x minus 4 upon x upon 4 when x is not equal to 0. then put it here, This is the limit of h tends to 0. 4 minus h is, in place of x you can write 4 minus h, the limit of 4 minus h minus 4, then upon 4 minus h minus 4. Then here 4 cancel, here 4 cancels. This is limit of h minus h mod upon minus h. Then this is equal to, and limit h tends to 0. In this limit h tends to 0. Then here we say that, limit of h, mod h is equal to, mod h means h upon minus h when h tends to 0. Then cancels. This is equal to limit h tends to 0, of minus 1, which is equal to minus 1. Then here now let us find out the RHL. This is LHL, Now let us find out the RHL. RHL means right hand limit. Now let us find the RHL. In case of RHL, limit x tends to 4 plus. Then take it limit h tends to 0, and this is 4 plus h. Then in case of in place of x you can write 4 plus h. Then write this, the limit h tends to 0, in place of x you write 4 plus h, which is equal to 4 plus h minus 4 mod upon 4 plus h minus 4. 4 cancel, here 4 cancels. You find mod of h upon h. This is limit h tends to 0. This is h upon h cancel, which is 1. Then this is limit h tends to 0 of 1, which is equal to 1. But in case of LHL, you find this is minus 1 and here this is plus 1. Then here we find that the LHL is not equal to RHL. The LHL is not equal to RHL means minus 1 is not equal to plus 1. Hence we say that the limit doesn't exist. Students, I have already told you, when you find the LHL, the left hand limit is equal to right hand limit, then can we say that the limit exists. Otherwise the limit doesn't exist. Here the limit doesn't exist. Now let us discuss some more examples, another examples, to give a better idea about the limit. Okay. Now let us discuss some more examples. If students, please do your worksheets and ask me your doubt. If any doubt persists, please ask me. I have already told you these things. I am already ever ready to clear your all doubts. Now let us discuss some more examples. Here another question says that, examples 2. I have here the questions, fx is given here, fx is given as fx is equal to 1 plus x square if the x is greater than equal to 0 and less than equal to 1. This is fx is equal to 1 plus x square and fx is equal to 2 minus x if x is greater than 1. Then you have to find out at x equal to 1, you have to find out so that the limit exists or not. If we find the LHL is not equal to RHL, then can we say that the limit doesn't exist. Let us solve the solutions. Let us find out. Here the LHL of, let us find out the LHL of fx, LHL of fx at x equal to 1. Then here the limit, LHL means the limit x tends to 1 minus. here x tends to 1 minus of fx, then this is equal to limit LHL h tends to 0, limit h tends to 0, then this is f of, you have to find out x at 1 means the f of 1 minus h. Here LHL, hence you take 1 minus h. If you have to find out the RHL, right hand limit, then you will take 1 plus h. As you have to find out left hand limit, this means x tends to 1 minus, then here you take the h is a small number, h tends to 0, then in place of x you can write 1 minus h. Then let us find out. When the x is less than 1, then this is fx is equal to 1 plus x square. When the LHL means the x tends to 1 minus, means x is slightly less than 1. Then in place of fx you can write this is 1 plus x square. Then here limit h tends to 0, then in place of x you can write 1 minus h, this is 1 plus 1 minus h whole square. 1 minus, in place of x you can write 1 plus 1 minus h whole square. Then here limit h tends to 0, then 1 plus 1 let us find out the 1 minus h whole square means a minus b whole square. Recall the identities, a square plus b square minus 2ab. Then here this is limit h tends to 0, here this is 2 plus h square minus 2h. As h tends to 0, this means this is equal to 2. You find the LHL here, this is 2. Let us find out the RHL. Keep it here and let us find out the RHL. If the LHL is equal to RHL, then can we say that the limit exists? Otherwise, we say that the limit doesn't exist. Then let us find the RHL. The RHL. When you find the RHL means limit x tends to 1 plus. This means limit h tends to 0, f of 1 plus h. Then you know when the fx is, you have taken the conditions fx is equal to 2 minus x when the x is greater than 1. You have taken the conditions, the fx is 2 minus x when x is greater than 1. Here the RHL means the right hand limit you take x tends to 1 plus means x is slightly more than greater than 1. Then in place of fx you write this is fx is here is equal to 2 minus x. Then here you have to find out limit h tends to 0. Then in place of x you can write 2 minus 1 plus h. Then here you open the bracket, this is 2 minus 1 minus h. This is limit h tends to 0, which is 1 minus h. As h tends to 0, this is 1. Here you find the LHL is 2 and the RHL is 1. This means LHL is not equal to RHL. Hence, the limit doesn't exist because you find the LHL is 2 here and the RHL is 1 here. When the LHL, I have already told you, when the LHL is equal to RHL, then can we say that the limit exists. In other case, we say that the limit doesn't exist. Now, let us discuss another examples. I have discussed more and more examples to clear your all doubts, because I have already told you when you practice the variety of questions which will be helpful for you in the exam paper. Then here the another question says that whether you have to find out either the limit exists or not. Here the conditions, the question says that if fx is equal to x minus mod of x upon x, when x is not equal to 0 and fx is equal to 2 when x is equal to 0. Then here this is the conditions. You have to find out whether the limit exists or not. Then when we say that the LHL is equal to RHL, then can we say that the limit exists? Let us solve the questions. Here the LHL of this fx at x equal to 0 is limit of x tends to 0 minus of fx is equal to limit of h tends to 0 of, in place of x we can write 0 minus h, because this is left hand limit and we have to find out the LHL at x equal to 0. We have to find out the limit at x equal to 0. Here the h tends to 0, then in place of this is x minus h, in place of x we can write 0. This is h tends to 0, this is 0 minus h. Then this is limit h tends to 0, then this is x minus mod of x, fx is x minus mod of x upon x. Then put in place of x you write 0 minus h minus 0 minus h mod upon 0 minus h. In place of x you write this, which is equal to limit of h tends to 0. Then this is when you open the bracket 0 minus h, then here the mod of 0 minus h means minus h, mod means this is plus h, and here this is minus sign, this is minus h, and upon 0 minus h means minus h. Then here you get the limit h tends to 0, and in the numerator this is 0 minus 2h means minus 2h upon minus h, minus cancels, h cancels. You get this is 2 constant. When h tends to 0, this the LHL is equal to 2. Then now let us find out the RHL. Here you find the LHL is equal to 2. Now let us find the RHL. Skip it here, and now let us find the RHL. If the LHL is equal to RHL, then we can say that the limit exists. Now let us find the RHL. Here the RHL is equal to the, you have to find out here in the same fx at x is equal to 0. Then here limit x tends to 0 plus of fx. Then here the limit h tends to 0 of f of 0 plus h, f of 0 plus h. Then this is limit of h tends to 0. Then this is here, this is fx is equal to x minus mod x upon x, h tends to 0. Then in place of x we can write 0 plus h minus, in place of minus this is mod of 0 plus h mod upon 0 plus h, which is equal to limit h tends to 0. Then this is open the bracket 0 plus h and minus h upon 0 plus h. Here plus h minus h cancel. Then here this is limit of h tends to 0. Then this is 0 upon h. When h tends to 0, 0 upon h means here this doesn't exist, you get infinite. Here the LHL you get 2 and the RHL is infinite. Here the LHL is not equal to RHL, this means limit doesn't exist. I have already told you students, when the left hand limit is equal to right hand limit, then can we say that the limit exists, otherwise we say limit doesn't exist. Students, please practice your worksheet. I am ever ready to clear your all doubts. Now now I discussed other variety of questions. Here another examples I have already told you. I have please practice variety of questions. Here in the previous examples we have discussed about whether the limit exists or not. To find the limit exists or not, we have to find out that when the LHL, we come to the conclusion that when the left hand limit is equal to the right hand limit, then can we say that the limit exists. In the other case, we say the limit doesn't exist. Here we discussed the examples in whether the limit exists or not. When we get the LHL is equal to RHL, then we say the limit exists. Then now let us discuss another examples. Here the question says that, here this example says that, here let f, here the fx is given, let fx is equal to be the functions defined as fx is equal to 4x minus 5 if x is less than equal to 2 and x minus lambda, x is x minus lambda if x is greater than 2. This is the conditions. Here the fx is 4x minus 5 and fx is x minus lambda. When the x is less than equal to 2, then this is fx is 4x minus 5. When the x is greater than 2, then this is x minus lambda. Here in this question, the question says that here the condition is given, limit exists. The given condition is limit exists. Here we have to find out that, to find out here the value of lambda, to find out the value of lambda. The condition is given, limit exists. This means the condition is given, LHL is equal to RHL. By putting these conditions, we can find the value of lambda. Now let us discuss. Then you know what is LHL? This is, LHL means left hand limit. When the left hand limit, when x tends to 0 of fx is equal to limit of x tends to 0 minus of f of at x, we have to find out at x equal to 2. This means the LHL is equal to, then here we have to find out the x at 2. Then this is in place of fx, we can write this is fx is equal to 2 minus h when h tends to 0. When h tends to 0, this is the left hand limit is 2 minus h. Then now let us discuss the limit of h tends to 0. In place of x, you can write this is 2 minus h. Then here the condition says that when x is less than equal to 2, fx is equal to 4x minus 5. Then in place of x, you can write this is 2 minus h minus 5. Then now open the bracket, limit of h tends to 0. This is open the bracket, 4 2 ja 8 minus 4h minus 5. This is limit h tends to 0, which is equal to 3 minus 4h. When limit h tends to 0, this is equal to 2. We find the LHL is equal to the, when h tends to 0, this is limit of the constant 3. The 3 is the constant. When you put the value of h is equal to 0, then this is the LHL is equal to 3. Here we find the LHL. Now keep it here. Now let us find out the RHL. Now let us find out the RHL. Here we find the condition. Here we find the LHL is equal to 3. Then now let us find out the RHL. Here the condition is given, limit exists means LHL is equal to RHL. Here we have to find out the value of lambda. Now to find out the RHL, limit x tends to 0 of fx. This is equal to limit h tends to 0 f of 2 plus h, the RHL. Here the condition is given fx is equal to, here the condition is given fx is equal to x minus lambda when x is greater than 2. As here you have to find out the right hand limit. Here the h tends to 0, h is the smallest number, and right hand limit, then in case of x you put this is 2 plus h. Then here in place of fx you write when h tends to 0, this is x minus lambda. In place of x you write 2 plus h minus lambda. Then here this is limit of when h tends to 0, 2 minus lambda plus h is equal to 2 minus lambda. Means here the RHL is 2 minus lambda and the LHL is 3. Here the limit exists means LHL is, the condition is given limit exists. This means LHL is equal to RHL. This means LHL is equal to RHL. What is LHL, students? Please recall. This is 3. Here 3 is equal to 2 minus lambda. This means lambda is equal to 2 minus 3, which is equal to minus 1. Now we find the value of lambda is minus 1. This is the answer of the question. Now let us discuss some more examples like this. I have already told you, please practice variety of questions. You do your worksheets and ask me your doubt. This for class 10 students, this is higher level IIT foundations. Then students, you have time to practice for higher classes. If you get a clear idea about the limit in class 10, then it will be easier for you in the class 11, because this limit is a class 11 syllabus, not class 10 syllabus. Okay. Then please be attentive in my class and go through my class regular, attend my class. I will discuss the problems, examples in depth. The syllabus will be covered in depth. I promise you, students. If you follow my classes regularly, there is no need of any extra classes. Here all JEE level questions from IIT foundations will be discussed in depth. All chapters will be covered. Now let us discuss another examples. Here another example says that here the conditions is given. Here another example, the condition is given if fx is given here. Suppose here fx is given here a plus bx when x is less than 1, and this is 4 when x is equal to 1, and this is b minus ax when x is greater than 1. Now let us find that here this what will be the possible. Here the condition is given limit exists. Here the condition is given limit exists. Then if you have to find out that for what possible value of a and b, here we have to find out for what possible value of a and b, what possible value of a and b, what possible value of a and b. Here fx is equal to f of 1. For what possible value of a and b, here fx is equal to f of 1. Now let us solve. Limit of x tends to 1, limit of x tends to 1 of fx is equal to f of 1. Limit of x tends to 1 is equal to f of 1. Then for LHL, limit of x tends to 1 minus, then fx is equal to, for x is less than 1, here the fx is equal to a plus bx. Then here in place of fx you can write when x tends to minus 1, then as the limit exists, this means the LHL is equal to RHL. This means x tends to 1 minus is equal to x tends to 1 plus of fx, which is equal to f of 1, which is equal to f of 1. Now limit of x tends to minus 1 means limit of h tends to 0, f of 1 minus h, which is equal to limit of h tends to 0, f of 1 plus h, which is equal to f of 1. Then now keep it here and discussed. Keep it here. Sorry. Keep it here, now discussed. Here the h tends to 0, 1 minus h. Then when the fx is given here, when the x is less than 1, the fx is equal to a plus bx. Then here put it this, when h tends to 0, and for here put this, the limit of h tends to 0, f of 1 minus h is put here, f of 1 minus h is put here, f of 1 minus h is equal to f of 1, f of 1, x at 1 is equal to 4, which is equal to 4, which is equal to 4. Then here the limit of h tends to 0, then in place of a plus, in place of x we can write this is 1 minus h is equal to 4. Then here the limit of h tends to 0, limit of h tends to 0, and a plus b minus bh is equal to 4. Then h tends to 0, this means a plus b is equal to 4. Then for RHL limit h tends to 0, f of 1 plus h is equal to 4. Then here the condition is given when x is greater than 1, here this is 1 plus h means x is slightly greater than 1. When h tends to 0, then this is b minus ax. Then here we can put the limit of h tends to 0, the limit of h tends to 0, in place of this is, in place of x we can write 1 plus h is equal to 4. Then here when h tends to 0, this is b minus a is equal to 4. As the limit exists, we first get the conditions a plus b is equal to 4. Then we get another conditions b minus a is equal to 0. Then by solving these two equations, we get b is equal to 4 and a is equal to 0. Here the question is asked, for which value of a and b the limit exists. For this value of a and b, we can say that the limit exists here. Okay. Now let us discuss another examples. I have already told you, please students practice variety of questions. Now think, I have discussed, at first I have discussed with you whether the limit exists or not. When we say that the limit exists, when the LHL is equal to RHL, then can we say that the limit exists. Then next I discuss the questions, the limit exists and you have to find out the given constants like lambda, m, n, and here the question says that the limit exists, then you have to find out the value of a and b for which the limit is exist. Now here the another questions. Here the another questions. I have already told you, please practice variety of questions. Here another questions, another examples. Here this example says that, if f is an odd function, note down the questions. If f is an odd function, let us discuss what is odd functions and even functions. Given through my functions and relations video, and you get the better idea about the functions. What is odd functions, what is even functions. Here the conditions is given, if f is an odd functions and if the limit x tends to 0 of fx exists, then prove that the limit must be 0. Then here the limit exists, then this means LHL is equal to RHL, then we have to prove that, limit must be 0. Here the limit must be 0. You have to prove this. Now let us the proof. Here the conditions. Here the conditions is given, fx is an odd function. The limit x tends to 0 of fx, here this is exist. This means the LHL is equal to RHL. When the x tends to minus 0 means LHL is equal to limit of x tends to 0 plus of fx. As limit exists means LHL is equal to RHL. Here the LHL is limit x tends to 0 minus, here the RHL is x tends to 0 plus. fx is x minus is equal to x plus. This means the limit of h tends to 0, f of 0 minus h is equal to limit of h tends to 0, f of 0 plus h. Then this is equal to h, this is the limit of h tends to 0, this is f of minus h, which is equal to limit of h tends to 0, limit of fh. As this is an odd function, the condition is given here, look at here, the condition is given here, fx, f is an odd function. This means f of minus h is equal to minus of fh. This is a odd function. This means f of minus h is equal to f of minus of fh. f of minus h is, as this is odd functions, this is limit h tends to 0, which is equal to f of h. This shows that as the limit is exists, this shows that, then taking the, keep it here. Students, keep it here and okay. Now let us discuss. As the limit is exists, the f of minus f of h is equal to limit h tends to 0, f of h. This is equal to minus, taking minus sign outside, limit h tends to 0, f of h is equal to limit h tends to 0, f of h, which implies that 2 of limit h tends to 0 of f h is equal to 0, which implies that limit h tends to 0, f of h is equal to 0. This means limit x tends to 0 of fx is equal to 0. Here we have to prove that limit exists and fx is an odd function. The given condition is here. We have to prove that this limit exists and the limit must be 0. Here we prove that the limit is 0. Now let us revise. Here the condition is given, f is an odd function. and limit is exist. These two conditions are given here. We have to prove that the limit exists and the limit must be 0. The limit exists means LHL is equal to RHL. Here the LHL, you have taken the LHL limit x tends to 0 minus fx is equal to limit x tends to 0 plus of fx. Then the LHL is when h tends to 0, f of 0 minus h. The limit h tends to 0 for RHL 0 plus h. As this is limit h tends to 0, this is f of minus h. Limit h tends to 0, f of plus h. As this is an odd function, f of minus h is equal to minus of fh. Then limit h tends to 0 minus of fh, limit h tends to 0 of fh. Taking minus sign outside, limit h tends to 0, f of h is equal to limit h tends to 0, f of h. Then taking this to RHS, we get limit of 2 of limit h tends to 0 of fh is equal to 0. This means h tends to 0 of fh is equal to 0. This means when x tends to 0 of fx is equal to 0. Hence, we prove this. Then students, today this much. In my next sessions, we will continue with this. Till then, happy learning and keep sharing my beautiful channel with your friends. Thank you, students.